Hi, this is a quick walkthrough of our MLOps assignment 2. In this video, I will demonstrate an end-to-end pipeline for cats and dogs binary image classification use case, covering data versioning, model training, experiment tracking, containerized deployment, CI/CD pipeline, and monitoring. I'll briefly highlight the key files and show how everything fits together in the entire project structure. The repository is structured to support the full MLOps lifecycle, including pre-processing, training, deployment, monitoring, and testing. Major components include DVC for data versioning, version for data models, data sets, and store artifacts, and matrices, creating reproducible pipeline, making the collaboration and deployment more reliable. Flask for inference, Docker and Docker Compose for deployment, GitHub Actions for CI/CD pipeline, and Prometheus and Grafana for monitoring. All source code is tracked in Git. This is a Git page for assignment 2. The data set is organized into the pre-processed and raw directories, as you can see here. And we have a DVC configuration file. To version the large datasets and pre-process outputs without committing them directly to the Git. This ensures reproducibility across machines and experiments. The pre-processing is done in preprocess.py. Images are resized to 224 cross 224 cross 3 as required for the standard CNN, and the dataset is split into training, testing, and validation as 80%, 10%, and 10% respectively, which is exactly as we require in the assignment. The basic transformation and augmentation are applied to improve generalization and ensure consistent input formatting. The model training is happening in the train.py. A baseline CNN model is trained for binary classification. All experiments are tracked in the ML flow, where I log parameters, training matrices, and artifacts. The ML run directory shows recording runs, including parameters like learning rate, epochs, and store artifacts such as trained models and evolution output. After the model is trained and serialized, the model is saved as model.pth, fulfilling the requirement for a standard model format. The same model can be stored as an MLflow artifact, allowing it to be reloaded consistently across different environments. For model packaging, the trained model is wrapped using a fast REST API, which is defined in app.py. The service exposes two endpoints, the health check endpoint and the service validation. A prediction endpoint that accepts an image and returns a predicted output with a confidence score. All dependencies are pinned in the requirements.txt file to ensure reproducibility. The inference is containerized into a Docker file, making the model portable and deployable across different environments. The image can be tested and built locally. For continuous integration, unit tests are written using PyTest. This includes the data preprocessing and model inference utilities. The GitHub Action workflow is configured automatically to install dependencies, run test, build Docker image on every push or merge request. Now we're going to see the Git page, how when we are pushing any change, we can go to GitHub Actions and it traces the changes and shows the various stages for the CI/CD pipeline automatically triggering like linting, test, build, deploy, and notify. For deployment of the project, we are using Docker Compose, which is user deployment target. The Docker Compose.yml file defines the inference service and related components. We can also run a simple smoke test to see if everything is working fine. Now you can see all smoke tests are passed, and it's giving a prediction of cat with a confidence score of 88%, more than 88%. If these checks are failing, then the pipeline is also designed to be failed. The Okay, and now we are going to uh, see how we can reproduce this locally. So all the dependencies are there in the requirement.txt file, as you can see here. And then we have a readme.md, which gives you how reproducible steps to run this locally. So we can clone the project from the GitHub using this command, and then we can install the dependencies, and then we can run this command in sequence, or alternatively, we can run this command directly. So we have trained the model for 25 epochs, if you see here, and then you can build the Docker and Prometheus and Grafana. So we can run the Docker, build the Docker using this command, and then for monitoring purpose, you have the Prometheus and Grafana. We can also see the GitHub page for the readme.md. It gives the you know entire structure of the project. If you look at the architecture and you know all the steps here, the user guide, model training, inference, deployment, everything. And finally, we also have the contributors for this project listed at the end. And if I go back just to show you the health check of the service and how the prediction is happening, so we can go to Docker and we can check the service. So service is running on this port, and we can run the Swagger to see the health check for the service. So if you see, I just executed, it says the status code as 200, service is up, right? And then we can do a sample prediction. So I can try to upload a file. I have image of a cat downloaded in my local folder. I can upload that. So uh, just to show you the image that I uploaded, the image is actually not very clear. If you look at, it's a side image and it's not very clear, but still the model is behaving good. It's performing good. So if I execute, you can see the confidence score and prediction. So if you see, it is predicting a cat with a 94, more than 94% confidence, right? Okay, and now we can go back to the Docker and see the Prometheus, status of the Prometheus. So we can do a target health check from here. It says the services are up, right? And finally, I can run the Grafana for monitoring. So if I run the Grafana, so if I go to dashboard and see the dashboard, so you can see we have done almost 12 predictions up to now, right? So it shows the total prediction, the average confidence of the predictions, and the latency, the time taken to predict. And we have confidence trend over time. We have a class distribution, so everything is getting shown in the Grafana dashboard. Finally, we come to the conclusion of this video. Thank you so much.